run a company called Object Style, and like I said, I prefer to write open source code, but we do write lots of commercial code as well, and this is where our experience with using Cayenne in high volume production environments comes from. So Cayenne is an ORM. An ORM is obviously intended to help you bridge the object relational divide, solve the what is called object relational impedance. That for you as a Java programmer, it means that you don't need to think in terms of joins and foreign keys and primary keys, and you think in terms of objects. You work with object graphs. So Cayenne is one of the mature and established solutions in this space. I know that probably most of you are using Hibernate or JPA, and we will do some comparisons. But keep in mind that we appeared at the time when actually at the same time when Hibernate was started, and we went our own parallel track. We have a little different view at how object persistence should be done, and I'll try to talk about this today. Currently, we are at version 4.0. This is still like alpha releases, but I've been using it in production for a couple of years already. 4.0 with all the latest builds, so it's pretty stable. But so if you are to try Cayenne after that, don't go with like old 3-line releases, go with 4.0. And of course, Cayenne is widely deployed. It's been used on very different projects across different organizations: government, education, commercial. Like I said, Cayenne has quite a lot of history, and most of it is good. Let's discuss the history. As I said, Cayenne was started 15 years ago in 2001, and if you remember, that was the year. There was nothing there, and most of you probably haven't been around, as professional programmers back then. But there was nothing but JDBCs. There were some early attempts to build persistence frameworks in Java, and actually everybody was building persistence frameworks in 2001, and none of them really survived. So Hibernate, Cayenne, and the later iterations like JPA, that's where it all went. So we kind of got it right from the first attempt. And later in 2006, we joined the Apache Software Foundation, and this was also like one of the great decisions that we made, because Apache is all about community, and I'll have a slide on that. And Apache is a great home for Cayenne, and it's been a great home for 10 years now. And just taking a step back from Cayenne, and I want to say a few words about Apache as our home, as an open source project. Apache has this informal slogan saying community comes first and code comes second, so community over code. And this may be a little counterintuitive because we all, if we work on an open source project, of course we produce the code. We don't produce mailing list messages, right? But this is kind of important to understand that the projects, they come and go, and it is important to form a community around the project if you want it to have a future. If you want to have people who will maintain it after the initial developers, for instance, lose interest or, I don't know, move to .NET. It actually happened. So one of our initial developers, he's from Ukraine, and Andrus, and he did lots of algorithmic work in Cayenne back then, like really like computer science stuff with sorting graphs and everything. So, and he actually at some point he did go to .NET. So it happened, so the whole Apache model actually is intended to ensure that the project health is not dependent on individual change in his mind or whatever. So it's all about building community from that consists of players from different organizations, that doesn't depend on one, say, big corporate sponsor. So that's where Cayenne is, and currently we have 8 PMC members, and PMC members in Apache terminology, so Project Management Committee, is sort of like a formal group of people who have binding votes on everything. So we vote on releases and so on. We vote on new committers. And you can also be a committer on the project. So it doesn't mean that we don't listen to you. You don't have a vote. So just send us your code and just get lost after that. Committers are actually, the candidates for PMC. Really, if they're interested in being in the community as opposed to just fixing a bug that is a problem in their application, for instance. So if they're interested to be around, we'll definitely do a vote and give them an offer to join. So Cayenne is a meritocracy, and we follow Apache philosophy in this respect. And as you know, like right now, Apache has I don't know, almost 200 projects by now, and we all lost track of them. But they all are encouraged or even required to follow the same approach, where everybody's welcome and community comes before code. So now let's actually go back to the code and do a little demo on how to. And I would like to demonstrate a typical scenario of how you might build a Cayenne application, and there are multiple ways you can do it in the ORM world in general. So if you imagine an ORM application, you have 3 layers of metadata really, and synchronizing this metadata is a big problem. It's kind of painful. So the first layer is a database. So database defines a schema. So it means there are some definitions of tables, column types, column names, and various constraints. Then you have your ORM model, whether implicit or explicit, that actually maps between Java and the database, and then you have your Java objects. All 3 layers have their own metadata, and we would like to avoid writing manually at least 2 of them. So we need to pick one and then kind of try to synchronize everything else. Currently in Cayenne you can do it a couple of different ways, but we currently are actively promoting database-first approach. So database is your source of metadata. You evolve your schema by writing migrations and so on and so forth. But then, like everything else, kind of synchronized automatically. And on top of that, you can do your customizations, customizing your object model. So let's get to the demo. Okay. So I'm doing it in Eclipse, and I'm generating an empty project. Should have probably done it before the presentation. Because there's a few more things to set up specific to this Maven project. So first of all, I would like to switch to Java 8, but of course Cayenne supports Java 7, and all the versions support like everything back to like Java 4. Okay, don't need any of that. So okay, we have our basic. Okay, no, doesn't want to be Java 8 yet. Even update project. Okay, now it is. So we have our Java project, but first let's start with creating an ORM model. And the first step would be we have a GUI tool called Cayenne Modeler. It ships with Cayenne, so it's a part of download. With database first approach, we're trying to minimize the use of the modeler, minimize the use of the tool, just make everything automatic, make everything sync. But it is still a useful tool to, first of all, to start a new project. And then to customize certain things that automated reverse engineering didn't pick up quite correctly. So first I'm creating a so-called data node, and data node is really just a pointer to a database server. And I have some presets and preferences, so that's my database. So I already have the database that was on the slide, this one. And I save it to my project. Main, and we need a resources folder. So it's a standard Maven layout, right? And now we can do our first database reverse engineering. So let's get a model out of the database. So we do re-engineer database schema. I already have all this pre-populated. I have MySQL running on Docker here. it already found that there are a bunch of catalogs. One of them is Cayenne demo, and after a second or so, we got our schema, and we have two types of entities in the model. First set is DB entities, so it's our tables. That's what we saw on the slide, and we have two object entities that correspond to our Java classes, and there is a mismatch, you see. So there's two object entities and three DB entities. That's because, of course, artist exhibit. This is our join table that really doesn't need a Java class. So we have a many-to-many relationship, which is modeled without this intermediate Java class. One more thing that we need is a Java package for these entities. So let me do a column object style. Oops. Cayenne demo DB. Well, of course, it can be anything, really. So now we created our second layer. So we had a database. We created our ORM, first version of that. And now we can create the third one just by clicking Generate Classes. And it already knows kind of where it should go. We did class generation. Let's go to the project and actually refresh it. And I will need to add another thing. We need to make a resources source folder. So we saved our model in resources. It has to be on class path. So it is right now, and it has two files. One is Cayenne project, another one is data map. So it corresponds to the structure here. So data map is ORM mapping, and project may contain multiple data maps. So we have it here, and as you see, we have some new packages, and we have some errors. And of course, we have errors because we didn't import Cayenne dependency. Let's do that. Let's include Cayenne dependency and a few other things just to help us later run the app. So we have what? We have Cayenne, we have MySQL driver, because we'll be connecting to MySQL, and we have some login set up so that our logs actually make sense, that we don't use Java util login. The errors are gone. Now let's look at the classes. For each one of the entities, Cayenne generated two types of classes. One is the one that we will be using. It's a subclass, and it's empty. So it's intended for you to put your custom code in or just do nothing with it. It's up to you. And another one is underscore artist. So it extends Cayenne data object, and we'll talk about the inheritance a little bit later. And it will be completely overwritten every time you do class generation. This is actually called, there is a name for that. It is called generation gap pattern. And it's a simple and easy way to separate the code that is generated by the framework from your custom code. Really very, very simple and useful. So in addition to the property methods and all, we have these two things, properties. So this is all our persistent properties. These are objects that provide metadata for properties and also help us to build criteria and all that. So we'll see that in a moment. So generation gap, we have pairs of classes, and now we can actually start using Cayenne. To bootstrap a Cayenne stack, we need to create something called server runtime. So this is an object that encapsulates Cayenne stack, and you can have multiple of those, but usually, like more often than not, you'll just have one for the entire application. And there's a builder, and for now we will use the minimal form of it. We just load our Cayenne project that we created. Cayenne project, and we do build. Okay, runtime is all good. But to start using Cayenne, we really need another object called ObjectContext. And ObjectContext is your window to Cayenne. This is something that you constantly interact with. So we create this context, and you can have many contexts. In fact, your applications can have very many contexts. Each context containing its own copy of persistent objects. So we have a context. Now we can write a query. So let's fetch all artists that for instance, have exhibits that are in museums, as opposed to exhibits, being in private collections and so on. So we are dealing with this art exhibit system, and there are artists, there are exhibits, and we would like to get a list based on some criteria. Cayenne has a number of queries, and query is an interface, so you can create your own query really, and there's like a whole list of different queries. We will use the most common one called object select. As the name implies, it gives you objects, and the whole API of that query is based on your object layer definitions, not on database layer definitions. Object select query. So it's all type safe, it all respects generics, and let's add a criteria. This is where those generated properties come handy. So we do artist, we look for our exhibits relationship, we chain it with a property from exhibit, so we do dot, and do exhibit place. And here we have a bunch of operations. To build an expression, we will use like ignore case. And for the pattern, we'll use museum. And finally, we need to do select context. Okay, so this is our query chain. It's really readable, and there's actually many more things that you can add to that, and we will be adding things as we go. But for now, let's just print the result and see what we got. Artists for each. Okay, and that would be okay. Artist use plus get name. Okay. So let's run that, see what happens. Okay, it's not in the history yet. Run as Java application. So it worked. It shows the whole startup sequence. It says that we're loading something here, the configuration, connecting to the database, generating SQL. Let me actually pull this out into a text editor to show you the SQL. This is actually very readable SQL, written in style the way you might write it yourself. So you can understand what's going on really. So it did all the joins for you. I mean, of course, that's an ORM, so that's its goal. So that's how it's supposed to work. Except that some alternative ORMs, they don't generate SQL as clean. It printed a list of artists. So all is good. I mean, this worked. Now what? Now let's go through a cycle of schema evolution. We're talking about artists and exhibits, but artists, they have paintings, right? So exhibits, they display paintings. So let's add a painting table and then see how this whole database first approach works. I have a SQL script here that creates a new table, creates a foreign key, and populates some data. So we run it. So we have this table here. It does have the data. How do we automatically pull it to Cayenne? Of course, we can go to the modeler and type all these new tables and relationships and attributes here, but it'll take lots of time and it'll probably be very error-prone. So instead, we need to import a Maven plugin called Maven Cayenne plugin. And it has a bit of configuration there. Build plugins. I'll show it in a moment. So we have a plugin. We specify everything we need to know. So the driver, data maps that needs to be synchronized, database connection information, right? And then we have two goals. One being CDB import, which, as the name implies, pulls the metadata out of the database into our model and tried to merge it. And the second one is cgen, so it synchronizes our ORM with Java classes. So we need to execute both of them, and hopefully everything will work and we'll have an updated schema. So let's go to the command line and do an mvn clean compile. Okay, it worked and it printed something about reading a list of database tables, right? And then something about generating classes. And as I said, it only generates the underscore classes. It doesn't touch your subclasses where you may have some custom code. But except for paintings, it wasn't there before. So now if we refresh, actually, for whatever reason, importing a plugin requires maybe an update. Okay, so we have our painting there. The rest of the schema is unchanged, and actually, I forgot to mention that. But if we change anything in the current classes, so like artist to exhibit, if we rename some of the object properties, they will also stay unchanged. So the merge is pretty smart in that respect. It will not mess up with your customizations, and you can do the cycles over and over and over again, and you will keep synchronizing your database. Your database model. So now we can actually go to our class and start using paintings. So here we print in artists, but what if we can also print the paintings? So we suddenly have a painting relationship. So we can do we can iterate over that and do a system out println. Okay. Painting get name. Let's run that. It worked, but as you see, so we printed paintings. But as you see, there are queries between each artist and its list of paintings. So when we fetch the artist, we didn't fetch paintings together with it, but it still worked. And unlike say Hibernate or JPA or whatever, so we didn't need to wrap it in a transaction, a single transaction, to actually start resolving relationships that haven't been resolved before. So we just read the relationship here. So here I'd say, so this method called in a loop caused paintings to get resolved on demand. Of course, this code is not very optimal because you go in a loop and you executing queries one by one. So we definitely, so this was good for demonstration of this feature, but we definitely want to do a better query, do a better job. And in Cayenne, in object select, or in general in Cayenne, there's a feature called prefetch. So you can say that certain related entities need to be fetched together with the main entity. So we just add this prefetch, and again we will use our property artist paintings, and there are different styles of prefetches. There are disjoint prefetches that generate separate query for each entity in the prefetch tree, and there's joint. So we'll use joint just for simplicity, and we rerun. As you see, the picture has changed. So first of all, the query itself, it now contains a join to paintings, left join for that matter, and also the results are all in memory. So you have control how much or how little of the object graph you read in memory, and if you can predict what relationships will be read, will be accessed, you can prefetch. If you cannot predict it, you just do your best, and then Cayenne will resolve them as needed. So this was all about selecting objects. Let's actually try creating new objects and modifying them. So let me comment this out so that it's not executed. Let's create a new object. And here you may have used to this what I call pseudo POJO frameworks that actually give you an illusion of that you're working with regular Java objects that are not persistent, that just kind of objects, and then somehow they magically become persistent. In Cayenne, actually all persistent objects, they live in the context. So object context is their home, so to speak. Each context has its own copy of objects. So essentially, when you start creating new objects, you create them via the context. So you register them with the context automatically and immediately. So for instance, if we create a new artist, Kazimir Malevich, right? Malevich. So the way that works, you do context, new object, artist. So it's already registered. It already has some persistent qualities, and when we save, it will be saved to the database. So we add Sorry. Okay, let me do that. Is it better? Malevich set name. He also has some paintings, and of course we all know the black square painting, right? We can all do it ourselves. So painting. We also create it by the context, and so the entity will be painting. Black square. How do we connect them together? For relationships, Cayenne generates also methods, and depending on whether it's a to-one or to-many relationships, there are special methods generated, and you can add it from either side, from either the artist or the painting. So let's add it from the artist side. Add to painting. So that's a to-many relationship. So there's a method like that. And you add a painting, and the good thing about it, you don't need to add artists to the painting. This is automatically done by this method, so it connects the relationship in both directions. Which is, first, it's a nice shortcut, so there's less code, and second, it actually maintains the model consistency. And the last thing we need to do is to commit our context. Again, as you see, there's no transaction management code. It's just context and then commit changes. So let's do that. Again, that worked. It inserted the artist, it inserted the painting, and the primary key that was generated for the artist was used as a foreign key for the painting. So everything went smooth. And now I'll go back to the slides to explain like the main points of Cayenne and what we saw here. Okay, first we started, we wanted to do our DB first flow, but we started with Cayenne Modeler. It helped us to set up the project, to create all the names and everything, and actually run our first reverse engineering. And maybe after that you can customize your object model again, because database naming is not always that clean and usable. So very often, when you're dealing with some like mainframe database that has column names that are just some letters, you need to rename everything. So then we synchronized our Java classes, and then we started writing our app. We started with runtime, and runtime is much more powerful, and we will see how you can use this runtime builder to customize the stack. Then we created ObjectContext, and ObjectContext is our window to Cayenne. It's our window to the database. So we ran the query, we created a criteria, even though like on the slides I have a little different query, but it doesn't matter, it really is the same thing. And then we also edited and saved objects, we created new objects, and of course if we start changing data and we just keep calling commit changes, it will save the deltas. It'll save all the changes. So now the interesting part, Cayenne versus Hibernate. I'm sure many of you, if you work with a database, I've still seen some projects that are done like in pure JDBC, and of course, there are things like MyBatis and so on, but the majority are still using Hibernate or JPA, right? And we are a solution in the same space. So we are an ORM. They are an ORM. What we do differently is, first of all, we are not obsessed with transactions. So Hibernate and later JPA, they came from the Java enterprise world that was all about EJBs back, 10, 15 years ago. It was obsessed with transactions. So all the solutions, they were obsessed with transactions, and somehow that remained to this day. So in Cayenne, I like an abstraction of a version control system where you get your stuff from the server, then you're not connected to the server after that. So you just work with your code, or like in case of Cayenne, of course, with your persistent objects, but you are not holding any open connection or anything. So you work with object graph. I guess the difference with version control, this sort of analogy breaks pretty quickly, because when you start expanding your graph, Cayenne will automatically generate queries, and you'll get more data, so your graph is inflated as you navigate it. So in Cayenne, transactions are implicit unless you want them to be explicit. So there are certain cases, yes, of course. I mean, when you need to put multiple operations in a single transaction, you can do all that. But to me, those cases are a real minority, and the fact that for many people they are not, their preferred way of doing things is because they read too many bad books, really. And you know, I'm telling this to the customers very often, and not everybody agrees. But anyways. Arguably, you end up with better use of your connection pool again. So if you don't have your database connection open from the moment a web request starts to the moment when it ends, this connection pool can be used by other threads, for instance. So we only create this microtransaction when commit is executed, for instance, or when select is executed. We also like get a connection, and then we release it when you get the data. So we're not obsessed with transactions. You don't need to scope anything in Cayenne. So, or actually, I take this back. You do. So the scope is object context. So object context is that storage of your objects that you're working with. That's a unit of work, meaning that nobody else can see what you're doing with your objects. And so if like multiple threads are editing the same object, they should be in different object contexts. And the first decision you need to make with Cayenne is like how to scope your object contexts. Because on the one hand, you have lots of performance improvements if you're reusing the same object context. So there is a very efficient cache attached to object context. There's also a shared cache that's shared between multiple contexts, but you know it's a little less efficient. But on the other hand, you don't want other threads to see your changes. So object context is fairly cheap. You create it when you need it. You decide yourself what's your scope, and you know once it's done, you don't need to close it. It's not a connection. It's not a session or whatever. So it's just a map. Really, so you just throw it away. There's no close operation or anything. So you can have as many as you want. Persistent object. As you've seen, we have a framework superclass, and I guess you know that's the least favorite part for many users actually. But if you think of it, as I said, there are those like pseudo POJO approaches that tell you that okay, so your object is really just an object. It doesn't inherit from anything. It inherits from object. It doesn't have any behavior. You work with it, but then somehow it's suddenly persistent, right? So what happens? Usually, what happens is either bytecode enhancement or a proxying of those objects, right? So in runtime, those POJOs are not really Java objects anymore, or they are, but their initial nature, you know, what you saw when you wrote the code, is thoroughly, you know, modified. So in Cayenne, we are being honest about it. So we have a framework superclass where all the functionality needed to the framework to actually get inside your object and do its work. It exists there, so it's really OO. There's no need for ORM annotations, especially with DB first flow. So you just keep synchronizing your database. So you're not modeling in Java. So we're very skewed towards like modeling on the database end of things. So in Java you just reflect what's in the database, but you can customize it a lot. But it's not your like primary place where you do modeling. And another cool thing is generic mapping. So essentially, we have this generic property access API in Cayenne data object, and this means what? It means that Cayenne runtime doesn't care that your object is an artist, or it doesn't care that the object is a painting. It's all Cayenne data object to it. So if you have like a string label attached to it, calling it, you know, so this Cayenne data object is an artist, and this Cayenne data object is an exhibit, for instance, it will recognize it, and you can have the entire ORM without having any specific Java classes, really. This means what? It means you can have your application compiled without knowing what's in the database. Then you can point it to some database, it will reverse engineer it, create a model in memory, and I don't know, do something else with it, like for instance, build a REST service, or I don't know. So that's probably the only ORM that allows you to create the whole model in a running application. So other good things. So until now we were talking on how we're different from other ORMs, but you know, another section is just good features. Dependency injection. Cayenne is built on dependency injection. Server runtimes that you've seen, it's just a little wrapper around a dependency injection container, which is itself like a very small little thing that we wrote ourselves. It's probably, you know, one of the smallest dependency injection frameworks in Java, it allows you to do customizations. It allows you to rebind standard services and provide your own implementations for various things. So in this example, we provide an alternative query cache provider. So you can switch to EH cache, or you can use something else. It's up to you. And the way you add it to runtime, when you create it, you do add module. We'll see a few examples as well. Nested contexts. So the context can have child context. So essentially, you can split your work into these revertible small steps, really. So you can have multiple contexts, and you can make changes in one of them, and then commit to parent without committing to the database, because your flow is not done yet. Then you go to another, you make some changes, and then when you commit to parent, some validation fires up. So you revert just this one little thing, and everything else that's already in the parent, it is preserved, and you can do something about your errors and then commit the whole thing without losing your other changes. So you can partition your change scopes, essentially. And an extreme case of nested context is remote object persistence. And what is that? It allows you to take your child context to a different Java virtual machine. So in one Java virtual machine, for instance, you run a server, you actually have a connection to the database, and then you can have multiple client machines that, I don't know, it can be like Swing applications or JavaFX or something like that, that also have all the nice ORM API, all the queries, the same model. So essentially all the capabilities, but they exist in a different VM. So you can have some server-side code, server-side logic that should not be accessible to the client. So this prevents you from giving clients direct access to the database. It's actually a pretty cool technology, and too bad it's not very popular even in the Cayenne community. There are some people who use it, but most don't. And the reason, I guess, that nobody's writing GUI applications in Java, right? So those people who do, they love it. And actually, right now we're updating it to do the wire to switch the wire protocol to HTTP2, and all those good things. Caching. We already saw how you can register like an alternative cache provider. So this is how you declare cache properties of a query. So on the query end, you don't want to know anything about provider. You just want to say, okay, so this query, it should be cached if possible. We don't know if it's possible or not, depending on the configuration of the runtime. And you can tag it with some name. And this name is just a name of a cache region, essentially. So depending on your provider, cache region can mean many different things, but usually it's just like an area where you want to put a bunch of things together and then invalidate them together if some event happens. So for instance, like an artist changes, and we have an annotation that automatically will fire an event and flush this whole group if it's configured to be linked to a certain entity update. So caching is declarative, essentially, and it's fully automatic in the sense that you don't need to generate a cache key. We actually analyze the query, and based on query parameters, we generate a cache key internally. So, and then, no matter where you use it, if you build a similar query with the same set of parameters, it will hit the cache. And then, if you have a good enough provider, like EH cache, for instance, you can configure the policies, how fast it expires, and so on and so forth. So it's really, it helps a lot in scaling your apps. Handling large result sets. Many tables in the database, they contain millions of rows, so you can essentially approximate them as some endless streams of data. So treating them as lists that you have in memory is really counterproductive, because your application will run out of memory pretty much immediately. So you'd like to have some streaming processing of data. The simplest way of doing that is here on the slide. You can do an iterate operation and just provide a callback to process every object in an open stream. So this actually connects to an open result set, and for each row it reads, it pushes it to Cayenne, and you can process it. A bit of modification on that, and actually a change of style. So instead of a callback, that's an explicit iterator. Batch iterator. This is about micro batches. Processing objects one by one is fine, but then usually processing means what? Means you want to read some data, maybe you want to commit some data, you want to create some new objects, and you want to commit it, and you don't want to commit this millions of objects one at a time, really. So you would want to separate that in batches contain just an X number of objects in memory, and when the batch is processed, you do a commit in a parallel connection. So that's how it's done. So we have this batch iterator that gives you the whole like micro batches of objects that can be processed and committed, for instance. Cayenne-crypto. Cryptography is an interesting topic, and while writing that, I try to get like deeper into that, but not too deep, because you can really get lost there. Cryptography is nice, and we're used to encrypting data in transit, right? So the whole TLS thing, HTTPS, this is all about data in transit. We rarely think about encrypting data at rest, so data in your database. But even if you have the most secure database ever, you're probably making backups, right? So and they are sent off-site or somewhere, or they're stored in the cloud. They can be potentially stolen. And more people are starting to think that data at rest, it needs to be protected just as much as data in transit. So we created this solution. It was a customer request, but right now, of course, it's available to everyone. That provides transparent encryption. And again, so we're using Cayenne dependency injection mechanism modules. So we load a module in Cayenne runtime, and suddenly your code understands encryption. And it uses actually naming conventions to decide which columns need to be encrypted. But this is a customizable strategy. You can redefine that. So you end up you just add this module, you specify your keys, and actually specifying the keys is not an easy task. It looks easy here, but managing the keys is a whole other area. And suddenly you have you have encryption on the way to the database, and you have decryption on the way back. It's all transparent. Cayenne works with plain text. So to wrap up, why would you want to choose Cayenne? First of all, it's a stable, reliable, mature technology. It's been there for years. There are lots of success stories and lots of people who are using Cayenne. It's performant, it's user-friendly. We always tried, like from day one. So the people who started Cayenne originally, we thought that, okay, so we create this GUI tool. We want to make it user-friendly from the beginning. We don't want people to actually wait and like documentation or whatever, so that they just want to see like a simple tutorial and start working with Cayenne. It is opinionated so in many respects, because we didn't follow the industry on many things. And we actually started following the industry once. We tried to implement a GPA provider on top of Cayenne, and it was a disaster. Essentially, like everything we liked about Cayenne, we had to shut down and just redo it. So we abandoned that project, and it's dead for good. So we're not obsessed about transactions, so you have the smooth graph navigation and all. And last but not the least, it's community driven. There's no single company behind it. I mean, my company ObjectStyle employs a bunch of Cayenne committers, but we're not close to anybody else coming on board. Really, it all happens on the neutral ground. It all happens at Apache. And here's our resources. So our website, Twitter, GitHub. So thanks for listening. If you have any questions. Oh, there's a question here. Okay, right. So we have, first of all, like we originally had the string-based query language for criteria, for building criteria, and it's still there. Expressions can be created as strings, with parameterized strings. Then also at some point when we were wading into JPA woods, we did the whole JPQL thing. So essentially that's available, so you can build this whole JPQL query, it will work like Cayenne. And now I think one of the goals of 4.0 is to actually reconcile. So right now it's a different query class, so we want to reconcile it with object select. Yeah, so there is a query language. So you mean cascades that happen in the database as it? We know nothing about it because it's JDBC doesn't give us this information. But of course, you can invalidate a bunch of objects if you suspect that that's what happened. So essentially, if you have a knowledge of that there is a cascade in the database and there's also another thing, you can define delete rules in Cayenne, so you can emulate the same cascade thing right in the model. So you say that, okay, this relationship is cascades, and when your root is deleted, everything underneath is deleted in memory before commit. And then, all these objects will be deleted on commit. There's a question there.
Thanks for presentation. Sorry if this is obvious question, but regarding connection, is it still okay from performance point of view to have the connection every time open and closed? And if it's okay, probably did some performance test to prove that. Thank you.
So the question, if I understand correctly, is about like whether there's actual performance benefit in not keeping the connection open. Okay, so it's just I guess we're not testing the scenarios where it's always open. We test scenarios where it's not, and the performance is pretty good. I mean, we can have, like, for instance, our connection pools. Like I have a customer, National Hockey League. That's a pretty active web property, and for instance, there our ratio between like the request thread pool and the connection thread pool is like 3:1. So essentially, we can serve many more request threads with a smaller connection pool. Yeah. Integrated with Spring. Okay, that's a fair question. So first of all, server runtime, the whole idea is that it's very easy. So essentially, it's very easy to wrap it into any dependency injection framework. So essentially, if you know how to inject server runtime, so you already integrated Cayenne with your app, with Spring or whatever. And there are deeper things, like we had. We had a few clients that I'm aware of. So community is actually not very big on Spring, but some of our clients are, and they actually build things to wrap Cayenne into like the whole Spring transaction mechanism, for instance, yes, and DAOs, so data access objects, even though it's like an anti-pattern in Cayenne, really. So it's essentially if you wanna make it open, so just come to us. Let's talk about it. Let's talk about your needs essentially and how far you want to go. So there's no standard module, but as I said, like Cayenne is like really makes it very easy to integrate into any environment. So this was our goal, so that we're not like Spring specific or anything specific. All right. Any more questions? All right. Thank you.